Welcome. In this class we would cover the final topic that's left for geomorphology, that's mass wasting and landslides. Now when we talk about mass wasting, landslides is a part of mass wasting first of all. Now mass wasting can be explained in very simple terms as a zone of weakness which separates the rock or the soil material from a stable mass. So if I say this is a stable mass and any mass which is being separated from this would be an example of mass wasting. So mass wasting can take place in various ways. Some of the common types of mass wasting are the 5 types that we understand. The first is fall, topple, then you have slide, spread and flow. So let's understand this one by one. When I say fall, the angle is very steep. It's usually 45 to 90 degrees is the slope, and it is directly due to the gravity. The velocity is very fast and a direct fall from the top of the mountain to the base would be an example of fall. When I say topple, it means it's a kind of forward rotation which is along the axis or along the axis of its origin, and it's a kind of forward motion that occurs. So you have the whole mass that is moving forward. So that would be an example of topple. Again for topple, you have a gradient which is steep, usually 45 to 90 degrees angle, but speed is comparatively lesser as compared to fall. The next is slide. It's a kind of movement that occurs. It's a kind of slide which you understand in the playground. So you have a slide where you can slip the material. If you have a rock mass that's towards the top, it would roll down and move towards the bottom. So that would be an example of slide. Now slide is a downslope movement of the rock particle once it ruptures. Then you have a spread. Spread is a kind of cohesive force or a cohesive material that spreads on the surface. And finally is the flow. We'll understand flow in greater detail towards the next part of the section. So flow is a kind of movement when the particle is more or less fluid in nature. Now when we understand mass wasting, we have 2 basic ideas based on which we classify. First is the movement and second is the fineness of material. So how fine the material is and how fast it moves determines the actual type of mass wasting that would occur. So based on the movement and the fineness, we can classify the following types of mass wasting. So you have the movement on this axis, you have the fall, topple, slide, spread and flow, and towards the other side you have the rock, the coarse grains and the fine grains. So when you have fall, you have rock fall, debris fall and earth fall. So all this terminology will be known as earth, this would be known as debris and this would be known as rock. So what you do is you attach the words to the same word. So you have rock fall, rock topple. So once you know the elements on the 2 axes, you can fill in the remaining matrices here. So these are the major types of mass wasting that exist in reality. Now the most important among these that we would study in detail is flow. So rest all you can clearly understand by the name. We have understand what is topple, what is flow, what is slump. So you can classify if the grains are coarser, it would be debris fall. If the grains are finer, it would be earth fall, so on and so forth. Now the most important that we would understand for today is flows. Before that, let's talk about the velocity. When we talk about the velocity, if the velocity is very fast and the material is of rock kind, you have rock fall, rock avalanche and rock slide. On the other hand, if you have sediment, it would be debris fall, avalanche and slump. So you have the various things that are mentioned. If it is underlined, it's an example of fall. If it is in italics, it's an example of slide and so on. So this gives you an idea based on the velocity what kind of mass wasting would occur. So usually mass wastings are predominantly understood when you have high velocity that is being talked about. Now when we talk about flows, there are 3 basic classifications: 0 to 20% of water, 20 to 40% of water, and finally you have 40% and above water. So if it is 40% and above water, we call it water saturated streams and water saturated flows, or we also call them as streams. When the amount of water is 20 to 40%, we call those as slurry, and if it is less than 20%, we call those as granular flow. Now let's talk about slurry first. When we talk about slurry, you have three basic types of slurries that we would understand: the solifluction, debris flow and mud flow. Solifluction usually occurs in the colder areas. It's mainly due to the freeze and thaw action, that you have breaking of the rock particles that take place, and the velocity is usually slow. It's a kind of slow movement that occurs. When the particles, less than 50% of the particles are fine in nature, what occurs mainly is the debris flow. Now debris flow involves freeze and thaw action. It also involves heating and cooling of the material, and finally it involves like generation of irregular surfaces, which is mainly in the forms of ridges and furrows. And finally you have the mud flow. Mud flow occurs at a very high speed. It's usually wet material with more than 50% of the sand silt that is present in the mud. Now these are the slurry examples. Now when we come on to granular flow, the slowest one is the creep. The creep is very slow and small movement of soil particle that occur, usually because the particle size is bigger. It occurs due to wetting and drying of the soil. Then the next is earth flow. Earth flow occurs in mass, so you have a kind of liquid formation that flows mainly when you talk about volcanic eruptions. You have the flow that occurs, and that is known as earth flow. And finally you have the grain flow and debris avalanche. Debris avalanche is the occurs when it is a case of severe landslide. So you have whole of the debris that flows down or topples down. The velocity for debris avalanche is very high, and grain flow is comparatively slower than debris avalanche but faster than earth flows. And this grain flow, the main idea is usually occurs in the areas of sand dunes and towards the region where you have steep slopes. Now the most important for this class would be understanding the concept of landslide. So when we talk about landslide, we will understand the components of landslide first. So landslide is the distinct zone of weakness of the point of gravity, which I could say, which is caused mainly by the gravity. So you have the toe, that is the base of the landslide region, the foot where the landslide nearly stops. This is the main body, and the toe of the surface of the rupture. So here the rupture or the breaking of the landslide takes place. It's a zone of weakness, I could say, and from here you have the flow that takes away, and since from here it's the flow that takes away, you have the surface of separation that occurs here. You have cracks throughout the landslide that is present. The top part is known as the crown or the main scrap, and the surface from which it moves away is the surface of rupture or the surface of separation, and finally it moves down. So that is how the landslides occur. Now when we talk about landslides in detail, let's understand the causes of landslide. The causes of landslide can be clearly classified into three types. You have human induced causes. These include mining activities, deforestation, then you have the excavation, the leakages. So all those issues are related to human induced factors or human induced causes for landslide. Then you have morphological causes. Morphological causes include the tectonic movement. Then I can say the glacial rebound that occurs. So all the activities which are generated by nature, the freeze and thaw action, then you have removal of vegetation that could occur, heating and drying of the soil. So all those would be morphological factors, and finally you have the geological factors. Geological include the type of rock, the weaknesses, the zone of rupture, the classification of rocks, and the kind of the material that is present, whether the material is fissured in nature or it is a kind of well jointed rock structure. So all these causes landslide. Now once we know the causes of landslide, we can easily classify areas which are prone to landslide and which are not prone to landslide. When I say areas which are not prone to landslide, I can say those would be mainly the areas which are flat. So regions of flat topography with no joints, stable landmass would all be an example of region where you have no landslides that are present or which are not prone to landslide, I can say. Then you have regions which are prone to landslides. Those would be the regions where you have weak rock structure or weak joints. Then towards the top of the hilly region and the bottom. So when you have a sloping region, the top and the bottom are highly exposed to or highly prone to landslides. Then you have the region whether it is affected by prior landslide. So if that region was affected by prior landslide, it is more likely that in future the region would be prone to landslides again. So that is one of the primary reasons why an area is prone to landslide. Now based on this, we can classify landslides into certain types. When I say classification of landslides, we can broadly divide it into three types: the surface, slide and complexity. So when I say surface, slide and complexity, so complexity would be, or complex landslide would be a mixture of these. When we talk about slide, it can be again divided into three types: the block slide, earth slide. Block slide means the whole block falls as such or topples down. Then you have earth slide, where you have fine material that moves down, and then you have sliding of the rocks that takes place. Sliding of the rocks usually explain the bedding planes. So the base of the rock would be explained in the slides. And then you have the surface. When we talk about surface, we can classify it based on the curvature. So I can say it could be either rotational landslide or translational landslide. When I say rotational landslide, it talks about the curvature. So it is curved concavely upwards. So that would be an example of rotational landslide. And when it is translational, that means it's a kind of parallel landslide that occurs usually on a much planar surface. So this was the classification of landslides, its causes and the areas vulnerable to landslide. We will be covering few more remaining topics related to climatology in the further class. You can subscribe to our channel for more updates on geography. Have a good day ahead.